Assalamualaikum and hi. So today we're going to present about our lab 3 which is lab ulang balik bodoh. Aku lupa.
Ni bro, Ospf Single Area Configuration.
Terus cakap je kan. Okay.
Okay,
Start.
ready.
Oh, tak stop eh.
Tak. Kau nak start je?
Assalamualaikum. Okay.
Ah.
Assalamualaikum and hi. So today we're going to present about our lab 3 network protocol which is Ospf Single Area Configuration. So this lab 3, I'll be the leader for this group, and I'll be assign the task to every members we have here, which is Khairul, Shafik, Ahmad, and Emir Syazwan. And then we go to the next slide.
Okay, so here today I will be explaining about the mind map that we have done for the lab 3, which is for Ospf Single Area Configuration here. So what we expect from this lab is after we have done the lab 3, we will enable to configure the router ID for Ospf. And then we also will enable to establish OSPF on a specified interface. Then we also enable to view the OSPF operation using display command. Then also we also enable to advertise the default routes in OSPF. We enable to change the OSPF hello interval and that interval. And last but not least, we enable to change the OSPF route priority to manipulate DR or BDR election. So this is our mind map. So first step for this lab 3 is we have to prepare the basic configuration, or we have to prepare the environment as shown in the scenario. And then after that, we have to configure the OSPF. This is the most important thing in this lab 3, which is we have to configure the OSPF. After we have configured the OSPF, we have to verify the OSPF configuration that we have done. After we have checked all the verification, and then we have to set up the OSPF hello and that interval. After we have done the step, we have to advertise the default route. The default route is a backup route. And then after we have done the advertising the default route, the last step, which is the step which we control the OSPF designated router or backup designated router election. So to go through more deeply about this OSPF single area configuration, I will pass to my friend to show in the ENSP. Thank you.
Okay, thank you, Emir, for the mind map. So now, in this ENSP, we know this is the topology that we will use for our configuration of OSPF. So this is a simple topology. We use 3 router, router 1, router 2, and also router 3. So we can see at router 1, at the GE001, the IP address is 10.0.12.1, and at router 2 at GE001, the IP address is 10.0.12.2. So we also have a connection between router 1 and router 3. So we can see the at router 1, GE000. So the IP address is 10.0.13.1, And at router 3, GE000, the IP address is 10.0.13.3. So we also can see the loopback for router 1, router 2, and router 3. So at router 1, we have only loopback 0, which is 10.0.1.1/34. And at router 2, loopback 0, 10.0.2.2/24. At router 3, we have two loopback. The first one is loopback 0, which IP 10.0.3.3/24. And the second loopback is loopback 2, which IP address is 172.16.0.1/24. So this is our topology that we will use to configure the OSPF. So next, I will pass to Shafik. I will pass to Zamel.
So before we start our configuration, we have to read the scenario given. The scenario given is as the network administrator of an establishing small enterprise, it is required that a network be implemented using OSPF. The network is to support a single area, and with consideration for future expansion, it is requested that this area be set as area 0. OSPF is required to advertise default routes and also elect both a DR and BDR for network resiliency. So firstly, we have here is 3 routers that we have assigned an IP address for each of the router and the loopback address. So to see the IP address and the loopback address, we have to use certain command, which is display IP interface brief for each of the routers. So here we have R1, and as you can see here, we have the IP address that is assigned at each of the Ethernet cable, and that is for the R1. So for the R2, it is also the same. We also use the same command to see the IP address and the loopback address. So moving on to the second step, which is configuration of the OSPF. This step we have done in the before the video made, and we have assigned the value of 10.0.1.1 as the router ID for the R1. So for the we assign this value because it is for simplicity, because it is interface loopback 0 on the router 1. So we have done that, and you can see at the table below, and after that we have specified the network segment for the OSPF area 0 on this router, which is 10.0.1.0, 10.0.12.0, and also 10.0.13.0. So for the R2, we also use the same process, which is we use the loopback interface ID for the router ID, and we use the area 0 for the OSPF, and we also use the network address that we have used in the network segment. And that is also the same as in the R3, which is router 3. And after we configure the OSPF, it will automatically communicate one another to start the election of the DR and BDR. So to see that, we have to move on to the next step.
Okay, for the next step, which is step 3, after we have configured the OSPF, we need to verify the configuration by using the display IP routing table command in R1 like this. Okay, as we can see here, this is the OSPF that we have assigned, that we have configured before. Okay, for R2 also, to verify the OSPF configuration, we use the same command, display IP routine table, and we can see here the OSPF have been configured. And also in R3, display IP routine table. Okay, OSPF. Okay, next, after we verify the configuration that we have done, we need to test the connectivity between R2 and R1 at 10.0.1.1 and between R2 and R3 at 10.0.0.3. Okay, first of all, we go to our router to CLI and then we try to ping the address 10.0.1.1. Okay. Okay, as we can see here, 5 packet received, which is the connection is successful. And then next we will try to ping R3 at 10.0.3.3. Okay, also it is successful. Okay, next we need to display the OSPF peer by using command display OSPF peer. Yeah, wait, OSPF peer. Okay, as we can see here, DR, the designated router 10.0.13.1, and the BDR is the neighbor is 10.0.13.3. Okay, next for the DR 10.0.12.2 and the BDR 10.0.12.1. Okay, to see the condensed version of the OSPF peer, we can use this command display OSPF peer brief. Okay, you can see here the interface and the neighbor ID. We can try it on the other router also. Display OSPF peer brief. Okay, this is the neighbor ID for R2 and for R3. Display OSPF peer brief. Okay, this is the neighbor ID for R3. Okay, as for your knowledge, the DR election is non-preemptive, so it means that link R3 will not take over the role of DR from R1 unless the OSPF is the process of the OSPF is reset. Okay, next we move on to step 4, which is change the OSPF hello interval and that interval. Okay, first of all, we need to display the interface. Display OSPF by using this command, display OSPF interface gigabit Ethernet 0 0 0. Okay, as we can see here, the hello interval and that interval. As we know, we have configured before we start the recording, so we already changed the hello interval and the interval to value 15 and 60, which is before the value is 10 and 40. Okay, next, how to check the OSPF neighbor status. On R1, we can use the display OSPF peer brief. As we can see, this is the neighbor ID, and for R3 we can also display the OSPF, the interface of gigabit Ethernet OSPF interface gigabit 0 0 0. the hello and the dead interval we can see here. So after we change the hello and the dead interval, the router can ping each other back. As we know before, the hello and the interval is 10 and 40 before. After we change it, we need to change it back to make the connection. Okay, next we move on to step 5.
Okay, so for the step 5, we have to advertise the default routes in the Ospf. So first we have to configure the Ospf to advertise the default routes on R3. So for that step, we have done it before the recording. So to prove it, we will show you the IP routing table on the router 1 and router 2. So here you can see the IP routing table with for R1 and here for the R2. So which means that R1 and R2 have learned the default routes advertised by R3. So and next we have to test the connection by ping the R2 here and the loopback to here. So to do that we have to enter the ping command and the address. And here, as you can see, 5 packet transmitted and 0 packet lost. So which means the connectivity is success. So and for the next step is the step 6. We have to control the Ospf, the DR or BDR election. So here to start this step, we have to run the Ospf peer command. And here the command has been run, which is we want to view the DR and the BDR of R1 and R3. Here you can see the current status now. The DR is router 1 and the BDR is router 3. In this step, we have to change the DR into router 3 and the BDR into router 1. So to do that, we have to run the command or SPF DR priority. So for that case, we have done it, and to prove it, we will run the display OSPF peer command to view the DR and BDR of R1 and R3. So here, as you can see, the DR now is the router 1 and BDR is router 3. So we have changed it because here we can see that the R1's priority is higher than R3, so R1 becomes the DR and R3 becomes the BDR. So for the final configuration, we use the display current configuration command to see all the configuration that we have done to all the 3 routers. Here you can see the current configuration we have done to the router 1 and for the router 2. And for the router 3. And that's it. That's all from our group for the configuring of Ospf single area topology. And thank you.